Hi class, welcome back. So we're gonna start chapter 3 in this video. Chapter 3 is specifically regarding the application of the derivative. One of the important components of the application of derivative is knowing when the function is increasing or decreasing. 3.1 will help us identify that interval. In addition, we're gonna discuss how to find the critical number. We're gonna introduce what does it mean to be a critical number, and of course we're going to use this to define any functions that model any real life problems. So let's begin by introducing what does it mean for a function to be increasing or decreasing. um, so let's jump into this problem over here, this example. And the way I want to begin this description of how does it mean, we have to understand how we read a function, and we often read a function from left to right. So that means that when we are describing the function, we use that as a reference. For example, if we're starting from here to from 0 from the interval 0 to 0.5, we can see the function is actually, increasing. It means it's going up until it gets to this point, which is at uh, 0.5. Then it begins to decrease all the way until it reaches, x equals 2. So it keeps going down, it keeps going down, it keeps going down. A good way for us to reference this is as you're in a roller coaster. You feel in the roller coaster, you go in one direction, of course, right? Then what you're doing is you're going up, 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 up until you reach the top of the hill, and then you start going down, right? Down, down, down. That means that's how the function is behaving, right? But in this case, we define the value of the function as increasing or decreasing, as u moving up or moving down, as the value of x is moving to the left. If you notice, the values of x is going up, right? 1, 2, 3, 4, 5, right? It's going up. And so as x is increasing, we can see the function is behaving different forms. So we already talked about what happens between 0.5 all the way to 2, right? In this interval, the function was decreasing. But now from 2 to 3, in this interval of x, right, in these values of x, the value of the function is going up now, right? It's increasing, it's increasing. So there's a change happening in the function, and the change is that it's going up, it's increasing. And then we notice here, then between 3 and 4, the function is just stable, right? It doesn't change value. The value of the function is still the same, it doesn't change there. And then from 4 all the way to 6, the value of the function is increasing, increasing, increasing until it reaches this point, and then starts to decrease, right? So if you think about it again, as you being in the roller coaster, think about the value of the function is measures whether you're going up or whether you're going down, right? So anyways, that's pretty much how we define the function of increasing, decreasing. But this is not how we're gonna see it. The one of the things that we want to learn from this section is how to use calculus to determine whether the function is increasing or decreasing. Well, we already talked about that in this part right here. In this region, we know the function is increasing. But why do we know that? Well, if you create a tangent line, we know that the slope of this tangent line, is going to be positive. What I'm trying to say is that the derivative in this region, the derivative of this region of the function here, is going to be positive, positive. And then when it goes from 0.5 to 2 in this region, the function is decreasing. Well, what do we know? It's very consistent that any point on this graph, the slope, the point on this graph creates a tangent line whose slope is negative. Is negative. So what does that tell you about the derivative? It means that in this interval, the derivative will be negative, negative, and so on. So that's actually how we want to interpret, right? If we see here above, we're saying that the function is increasing on an interval if the derivative is positive, right? If the derivative is positive, just like we explained in a second. The function is decreasing on an interval if the derivative of the function is less than 0 or equal to 0. And if you notice here, between here and here, the value of the function is going to be constant. It's going to be constant if the derivative of the function is 0. And that kind of makes sense, right? Because in this case, if you create a tangent line, right, what is the slope of this tangent line? The slope of this tangent is going to be 0. So I hope that kind of makes sense. Here the slope is greater than 0. Here the slope is less than 0. Here the slope is equal to 0. So knowing that the slope of the tangent line kind of help us with the connection here. So that's pretty much what we're doing here. So we already kind of sort of talked about part of the solution for this problem. So what we're saying is that from 0 to 0.5, the function is increasing. And then also happens between 2 and 3, between this region, right? From between 2 and 3, the function is increasing. And then from 4 to 6, the function is increasing, right? So we're able to define the interval where the function is increasing. Of course, the slopes there is going to be positive. In the similar argument, we can say that between 0.5 and 2, the function is decreasing, so the slope is negative. But we can say that between those intervals, the function is decreasing. And the same argument follows between 6 and 8. The function is decreasing, right? It's going down. So that interval is that. And from the interval from 3 to 4, the function is not increasing, nor increasing nor decreasing. In fact, it is constant. So we see here that this will be a value of the function where it's constant. And lastly, this actually helps us determine something in particular. We're very interested in the behavior of this function when it reaches this point right here, or when it reaches this point right here. This is known as a critical number. In fact, this happens whenever the derivative, if you notice, remember the slope of this is 0, the slope of this is 0, the slope of this is 0, the slope of this here is 0, because if you create a tangent line, the tangent line is a vertical line. Well, those are one way to find critical numbers. So that is the definition of a critical number. A critical number of a function is located in a domain if that value for the derivative is 0. Another place where it could be also a critical number is whenever the derivative is undefined. It's when the derivative is undefined. But again, a needs to be part of the domain, meaning that when you plug in a into the regional function, you should get a real number, right? So we're going to be finding, this is actually going to be a very important concept of finding critical numbers, because this is going to help us find more information later regarding the behavior of the function, but also in real life problems. And lastly, if we define a critical point, well, a point is composed of an x value and a y value. And we already know, if we assume that a is a critical number, then that means that will create a critical point if we can find the corresponding y value of this x value. Let me say it again. If we already know that x of a is a critical number, because when you plug it in the derivative, it gives you 0, or when plugging it in the derivative gives you undefined, then we already know that this should give you a value on the function. This point in the function is going to be a critical point. It's a very particular point. So that's actually this point right here. It would be that in this case x equals 6 is a critical number, but let's say that this is the value 10 here, then this will be 610, right? That point, the point is this point right here is the critical point. This right here is known as a critical number, right? This distinction between a critical number and a critical point. A critical number is just a number. We know that it's just a specific number, a real number. critical point, we know that we refer that to a coordinate, an x and y. So there's a distinction, very clear distinction between both of them. It is interchangeable. We often ask for one or the other, but because they're very specific for the purpose of the problem or the description of the graph. So anyways, this is it for the introduction and example 1. So we'll continue